Hi everyone. Our topic is security and privacy in IoT. My team members are Sandhya, Niharika, Abhishek, and Srilekha. The main abstract of our topic is Internet of Things is getting popular in nowadays. The scope of this work is based on the data privacy and data security and data analytics. The main theme of IoT is implement the interconnection of devices which are embedded on day-to-day use things. When coming to IoT, there will be many issues related to security and privacy. Since main focus is on sharing of data which contains a large amount of private information. Thus, there are more data leakages, security issues, and rise of cyber crimes due to accessibility of data anywhere around the globe, which is the biggest challenge we are facing nowadays. There is a need of increase in data security due to their issues that are occurring globally. Even though machine learning and deep learning provides remedy for for few security issues, it has several backlogs which requires to be covered in IoT at the end. This paper mainly focus on challenges faced in security of IoT and process to overcome this type of issues and measures the must taken to protect published data in the cloud to avoid data violation. And the main objective of our top project is security issues arise due to bugs in the programming which results in the backdoor installation and creation of malwares. Also, IoT involves the use of computers for storing, retrieving, and manipulating data. It is the part of information and communication technology that face several security issues and cybercrimes. IoT development brings about the both new security concerns and the regression of existing ones. The variety and the size of the sample are the primary causes. Physically, objects which are associated with IoT are term things. The vulnerability, the things of the face categorized into two types, diversity and the communication. The security issues in the Internet of Things are mainly arise due to the bugs in the programming, which results in the backdoor installation and the creation of malware. Even the accessibility of data from the cloud from anywhere creates security and privacy issues due to the unauthorized users. Data privacy elect information about name, password, date of birth, phone number, and some passport details, and also some few more details which will be accessed by the third parties. Even though big data analytics and machine learning provide security, still we have some leaks are bound to occur. These security issues are more complicated than the ones we currently face due to the variety of the scale of the things in the Internet of Things. We came across several violated servers like service legal agreements due to these security breaches. Internet of Things is heterogeneous, and we discussed the challenges faced in the IoT and the prevent models are used to security and the privacy concerns. To prevent these security breaches, we need an hands-on privacy model which provides systems with strong data privacy techniques. The vulnerabilities that IoT faces are categorized into several types, and the different communication media faces different issues as IoT is a heterogeneous.
Hi, this is Sandhya Putnuru. Now I'm going to introduce about some challenges faced in IoT. The first challenge I'm going to discuss is object identification. A proper identification of the device is the main part of IoT. The identification number should be in such a way that it doesn't only identify the object but it also should reflects the properties of the device. Object identification is the main challenge to ensure the integrity of records used in naming architecture. Domain naming system is the best example for identification that is practiced in internet a lot. It contains an iterative and recursive DNS request. Each internet client has a DNS resolver configured in its operating system. A recursive DNS query is when the resolver queries DNS server until it can provide a certain answer. An iterative DNS query is when the DNS server returns an answer without querying the other DNS servers even if it cannot provide a certain answer. There are possibilities of attacks in DNS system also. One of the main attack is the poisoning attack and the other attack is the man in the middle attack. The reason why DNS catch poisoning attacks are possible is that DNS servers are using an UDP protocol which doesn't require any handshake or authentication. It sends a UDP packet with the question and waits for to receive the UDP packet with an answer. Thus, in the middle, the attacker can be able to fake the information. To forge a DNS response, attacker need to satisfy only three conditions. The one is every query is sent with the transaction ID and the response must be in the same transaction ID. Second one is response must come from the same IP address to which the query was sent. The third one is the response must come to the same UDP port which the query was sent. By satisfying these conditions, the attacker will be able to fake the information and even can listen to the important information in the main website. Thus, poisoning attacks injects counterfeit DNS records into victims' cache and directly compromises the resolution mapping between naming architecture and addressing architecture. Without integrity protection, the entire naming architecture is under risk. Hence, an extension called Domain Name Service Security Extension is introduced to reduce the risk factor. Object name service is to locate the data and service associated with EPC, electronic product code, which is inspired from DNS and introduced into the internet. One is authentication in IoT. Authentication is the process of identifying the device. This is categorized into two types, distributed and centralized. Distributed stores the certifications in the device and validate the authentication, while the centralized trusts the central or any other third party and stores the authentication certificates and manages the authentication for the overall network. Originally, authentication has been accomplished by using a variety of techniques, including ID password or pre-shared secrets and public key crypto systems. The public key encryption protocol is used by browsers to authenticate websites and by websites to authenticate users in the internet today. Passwords are even worse in IoT scale authentication than they were in internet scale authentication. Even the lack of global root certificate may threaten attacks and also hinders feasible schemes from actually being deployed. The work of managing skills will become challenging due to the items continuously expanding. There is an attempt going on to resolve this issue, but there is still no standard solution. Let us consider an example of sending a health data. The various medical devices on the left must authenticate with the local gateway. When sending this data to the cloud destination, the gateway must first authenticate there. When obtaining the data, the applications on the right that will evaluate and present this health data must also authenticate with the cloud. This is the entire process of authentication. Even the communication protocol also plays a vital role, which is used for transferring data. Let's take the example of X509 certificate, which provides security for all the certificates but also uses too much computing power, electricity, and internet bandwidth that is that is to be used in IoT devices which has low resources. Hence, research is going for better solutions. Authorization in IoT. Authorization is the process of providing permissions. Two standardized frameworks for authentication and authorization that specifically support are OAuth 2.0 and OpenID Connect 1.0. Both allow the user to actively take part in distribution of tokens to applications that are looking for user data, whether it is personal or health related. This can offer effectively privacy control. Authorization can be achieved by data-based or crypto-based access controls. The IoT objects or networks are heterogeneous and complicated, which may preclude the use of conventional authentication and authorization techniques. The work of managing keys will become challenging due to the object's continually expanding number. Despite research efforts to address the issue of object authorization, there are still no widely accepted guidelines or standards in this field. Privacy in IoT. The main feature of IoT is not limited to data browsing on the internet, but it also collects daily data and responds accordingly to give the better response. This includes a collection of user personal data which may have several issues since it will be treated as violation if the data is leaked. People also may find it challenging to learn that their personal information is being collected. Devices in public places have the ability to automatically gather information, sometimes relying on feature users to choose not to have their information collected. When collecting data, many preventive measures should be taken. Some of them followed by prominent cloud companies are device access, device signature, data security solutions, commands, software decisions, and physical actions. Data anonymization also includes cryptographic encoding followed by the concealment of data. The second category is erasing the direct links between the owner and the user. In the end, data to be shared between the devices which are need to be encrypted needs homographic encryption on which research work is still going on to come up with a better solution. Wearable and home IoT devices frequently collect personal information, including biometric data such as voice and personal preferences, such as eating habits and preferred TV shows. These devices and the data they collect can be used to provide great convenience and benefits to the consumers. But in the same way, they need to be secured in order to maintain the privacy of the customers. So, privacy has a great importance in IoT. Malware in IoT. Malware is a major security threat in IoT. Detecting them is one of the major challenges. IoT malware typically has number of traits, including the ability to perform DDoS attacks, scan open ports for IoT services like FTP, SSH, or Telnet, and carry out brute force attacks to gain access to IoT devices. IoT malware detection faces highly particular difficulties, particularly when trying to identify cross-architecture IoT malware because of lack of security design and the unique features of IoT devices, such as heterogeneity of processor architecture. The security community has therefore concentrated its research in recent years on the IoT malware detection arena. Numerous studies used well-known dynamic and static analysis to find IoT malware. However, when it comes to multi-architecture problems, static-based approaches work better. Malware detection in IoT devices is quite challenging. The running of security protocols may consume more energy, but devices that are designed with battery are to be worked with low energy to preserve the battery for the entire day. Even increasing the capacity is not possible since they need to be available at low cost. The analysis of malware detection contains several types. The first is static analysis. It extracts low data and consumes low power. The infected file is inspected and analyzed without executing the file. It tracks all possible paths and has low level of false possibilities. Dynamic analysis. Compared to static analysis, dynamic analysis is not good. Infected file is inspected during the execution due to which malware function doesn't change its behavior, mostly used for detecting new malware. Hybrid analysis. It is a combination of two analyses to overcome the challenges of previous techniques. Even malware techniques are classified into three types based on the analysis. Signature based technique. Files that are analyzed and compared to the existing list. If they are listed in the list, they are considered malware. Behavior based analysis. This contains two processes by comparing the new program with the old function which detects most malware but costs high, and the second process compares the malware with the old one. Specific Specification based technique. This technique is hybrid model of the above two techniques that detect based on specifications that are based on different features. Below is This figure represents the malware analysis and techniques. As explained before, these are the malware analysis and malware techniques divided into three types. Malware analysis is divided into static analysis, dynamic analysis, and hybrid analysis. Malware techniques are divided into signature based technique, behavior based technique, and specification based technique. Security issues from my Android. Android smartphones are more vulnerable to viruses and malware that these criminals release. Because Android powers so many modern mobile devices, it is also more frequently attacked by hackers. The Android operating system is more appealing to cyber criminals due to its widespread adoption. Users are tricked by attackers into downloading software from dubious sources. When a user installs one of these APKs, potentially harmful software could be found within it, granting the attacker remote access to the mobile device. Although Android security has improved, it is still less secure of the two operating systems. However, you can never be completely safe from security flaws and zero-day attacks, regardless of whether you use an Android or iPhone. Any type of phone, including Android and iPhone models, can be hacked. We advise all users to learn how to spot a compromised smartphone because anyone might be vulnerable to phone hacking. Software vulnerability. The present security research field places a lot of emphasis on software vulnerability in addition to the authentication and authorization issues. Software vulnerabilities are bugs that cause security problems. Attackers can use this information to target a large number of missions when new software vulnerabilities, often known as zero days, are found. Unsecure communications are one of the main hazards posed by the Internet of Things. Programming errors made by developers are inevitable while a piece of software is being developed. Attackers can use this information to target a large number of missions when a new software vulnerability, often known as zero days, are found. Global trends and insights help you comprehend the panorama of vulnerabilities and develop plans to safeguard the things that are important to your organization. Unsecure communications are one of the main hazards posted by the Internet of Things. Data communications between devices are vulnerable to third-party inception. Threat actors might be able to obtain sensitive data like passwords or credit card numbers as a result of this.
Hi, I'm Niharika. I'm discussing about data privacy models in IoT. So to secure data from different attacks, there are many kind of approaches. Among them, K-anonymity is one. K-anonymity is a model for protecting privacy. It applies to specific type of data. So we can take input as table and the output is table of same dimensions in which entries have been generalized. Here generalization means replace a single value with a set of possible values. For example, the number 2 is written as a set of 1 comma 3 and another one you can take as if you take male as input, then the generalization output will be set of male comma female. So by this we can protect our sensitive data. Let's consider a hospital data set containing 100 people and their basic identifying details such as name, zip code, age and gender. So here the health information remains confidential. Therefore, K-anonymization could be used to eliminate some identifying characteristics completely and generalize others. Other information like a zip code can be geographically expanded. So this keeps the usefulness and efficiency of the data. By using the re-identification or the process of tracing data routes back to the person it is linked to in the actual world, hackers or other parties are prevented from being able to access the sensitive information. The second approach is L diversity. L diversity evaluates the diversity of sensitive values for each column in which they appear. It is a property of a dataset and an extension of k-anonymity. A dataset has L diversity if there are at least one different values for each sensitive characteristics. So the principles of L diversity is the if the equivalence class in a K anonymous table has at least one well represented values for each sensitive attribute, the table is said to be L diverse. So the principles of L diversity are distinct L diversity, entropy L diversity, and the recursive one. The third approach is the T closeness. In T-closeness, the K-anonymity stops identity theft but does not attribute transparency. So to solve that problem, L diversity requires that each equivalent class contains one value for each sensitive attribute. However, L diversity has some drawbacks. So to overcome that, T-closeness requires that the distribution of a sensitive attribute in any equivalent class is close to the distribution of a sensitive attribute in the overall table. So here privacy is measured by the information gain of an observer. Information gain equals to posterior belief minus prior belief. So by using these three principles, we can secure our data. The other topic which I want to discuss is the security protocols. In that, the first protocol is MQTT. One of the most widely utilized security protocols for the Internet of Things is MQTT, which stands for Message Queuing Telemetry Transport. It is a messaging transport protocol for client-server communication. The MQTT protocol utilizes TCP or IP or other protocols that offer desired lossless two-way associations. Here the features of MQTT are easy and quick data transmission is provided by this simple and incredible lightweight protocol. MQTT is created for limited devices as well as low bandwidth, unstable or high latency networks. And for IoT applications, it works perfectly. And the second one is the COPE. COPE stands for Constant Application Protocol. It is a web transfer protocol. Was created for constrained systems such as microcontrollers and the constrained network known as low power or loosey networks, one of the most well-liked protocols for securing Internet of Things application. COPE is built on the REST model just as HTTP. Clients use techniques like get, put, post, and delete to access the resources that servers make available under URLs. COPE is extremely resource efficient both on the network and the device, and it manages with UDP on IP rather than a convoluted transport layer. COPE relies on UDP security feature to protect the information because it uses user datagram model to carry data. COPE uses datagram TLS over UDP. In order to integrate with the web, COPE has been intended to have a simple and user-friendly interface with HTTP. COPE also supports features like multicast support and low overhead concerns, which help to increase security for the Internet of Things. The third one is the DTLS, which stands for Datagram Transport Layer Security. It is a security protocol for the Internet of Things. It is intended to safeguard data transmission between apps that use datagrams. It provides the same level of security and is based on the Transport Layer Security Protocol. The basic goal of DTLS is to slightly modify TLS in order to address problems like data loss and reordering. The DTLS protocol preserves the semantic of the underlying transport layer. As a result, associated stream protocols do not cause delays. The features of DTLS or a retransmission timer is used by the DTLS to address the packet loss problems. The client retransmits the data if the timer expires before it receives the server's confirmation message. Even for payload data, DTLS is unstable and does not ensure data delivery. And in DTLS is used in applications include live video feeds, video streaming, gaming, etc. The fourth one is 6LoWPAN. It is a protocol for low power networks such as Internet of Things systems and wireless sensor networks is 6LoWPAN, and it stands for IPv6 over low power wireless personal area networks. And it is a in low 6LoWPAN network, data packets is in the form of IPv6 or transported over various networks using 6LoWPAN. It gives direct connectivity to a number of networks, including direct communication to the internet by offering end-to-end IPv6. Communications between end users and the sensor network are protected using 6LoWPAN. In areas like smart house automation, industrial monitoring, smart grids, general automation, etc., 6LoWPAN is crucial and it is important. And the last one is the Zigbee. Zigbee is thought to be a cutting edge technology that offers security for Internet of Things applications and devices. It enables effective machine to machine communication over distance of 10 to 100 meters in embedded lower power. Zigbee devices like audio systems, it is a wireless open source technology that is affordable. Zigbee supports two types of security models. One is the centralized security network and the distributed security networks. Zigbee offers standards at all layers, allowing for interoperability between goods made by various manufacturers. Zigbee employs green power, which enables low energy cost and consumption, and also Zigbee supports a large number of devices, which aids in the scalability of the networks. These are the benefits of the Zigbee. And these are the top 5 security protocols in IoT.
Hello, this is Srilekha, and as my teammates have already discussed about the importance of IoT security in the previous sections, let us see some of the best principles and practices that needs to be followed in order to secure an IoT network. It is very critical to audit your devices and be aware of every device that is plugged into your organization's IoT network. The problem is that if you rely on manual audits, this will get more difficult the larger your IoT network is and the more devices that gets added. So it is very important to automate the process of auditing. In the initial stages of an IoT project, it is best to set up a device or asset management and tracking system as soon as possible. Even for existing IoT networks, it is integral to incorporate a device management solution into your network. Moving on, it is very important to identify and list all your endpoints. We need to keep in mind that adding new endpoints to an IoT network can present vulnerabilities because they could serve as entry points for hackers into the network. We need to list all the probable endpoints of the entire IoT network based on the device audit that has been done. Remember that certain devices may have several endpoints and that devices from various manufacturers may operate differently. This heterogeneous quality and the scale of things in IoT can make a network more complex, but nonetheless, all endpoints should be identified, profiled, and subjected to regular monitoring. While it is ideal to always secure every endpoint in an IoT system, This ideal situation isn't always possible given our limited resources. So, prioritization is crucial for this reason. Indicate the importance of each asset and endpoint on your IoT network, and then ensure the dependability of operations so that you can order essential assets in your IoT network while adopting IoT security. As a general rule, everything should be updated as soon as new updates becomes available. This holds true for both software and hardware solutions, such as programs, operating systems, firmware, etc. The updates should be installed as soon as they are available, especially if it is a security patch. Also, avoid making the same error by using software that isn't patched. This leads to many successful data breaches. If possible, it is ideal to set up automated updates. If not, we need to make sure that every update is checked frequently and implemented as soon as possible. Regular penetration testing should be conducted in order to check each device's defenses against incoming assaults and thoroughly assess each hardware and software solution before incorporating them into the IoT network. We might also need to run additional tests to look for potential vulnerabilities depending on the solution or the use case. Before integrating any products or services into an IoT network, it is ideal to give them a thorough inspection. We need to remember that any of these items may contain potential security flaws and that these flaws must be found before users can access them. Network segmentation. When coming to certain IoT devices and equipment must connect directly to the internet rather than through an IoT management system, it is optimal to segment these devices into a separate network with restricted access to rest of the IoT network in order to safeguard the security of the IoT network. This will let us monitor the network segment more effectively for signs of malicious activity and stop these problems from spreading to the main network and compromising the user's data. The securing of human resources is as essential as securing the privacy and security of all the hardware and software devices. It is crucial to educate about the best ways to use IoT devices and the IoT network as a whole to ensure secure use, as many individuals are unfamiliar with the IoT operations and security. All the potential access points must be securely protected, and security personnel must be trained in this process. This can entail exposing them to fresh infrastructures and security difficulties. To keep them informed of the newest risks and IoT security techniques or measures, training should be undertaken on a regular basis. Proper accountability and governance should also be established in order to find the solution of problem. Different IoT devices employ different protocols. As we have discussed, IoT devices use a variety of networking protocols to connect, including the widely known Bluetooth and near field communication, also known as NFC, as well as the less well known NRF24, LoRa, LoRaWAN, optical, and infrared communication. In order to minimize risks and stop attacks, administrators need to be familiar with all the networks protocols utilized by their IoT systems. In addition to all of the above, there are some other practices that can be followed in order to secure your network further, such as updating passwords and credentials. Although updating passwords may seem like an outdated practice, many devices have a vendor supplied default password, and the cyber criminals can easily access these passwords and exploit or gain control of the devices. Maintaining a good password hygiene by updating passwords and credentials frequently is an important step that should be managed to ensure that devices are secure at all the times. Using a multi-factor authentication that requires users to provide two or more verification factors before gaining access to a resource will not only able to successfully complete each aspect of authentication but also improve the overall security of your IoT network and adds an extra layer of protection against a cyber attack. While securing the network 100% may seem impossible with the recent improvements in the technology, When the data has become the ultimate power, it is very important to constantly work on securing your IoT network and prioritizing the safety of the data. Therefore, before implementing any IoT project, a thorough assessment of security risk is required to identify all the pertinent and underlying issues. IoT won't be effective in the long term if data security and protection are not sufficiently strong. Therefore, it is a challenge for any manufacturer to add adequate security measures to every stage of the development process and the equipment operation. In order to maintain the confidentiality, integrity of the user data, it is crucial to provide a framework for realizing and analyzing security risk within the IoT. Users must be aware that the Internet of Things is a dynamic, evolving field and that security must constantly adapt to these developments. Finally, this study gave general outline of the theory underlying IoT and its challenges, some of the attacks in IoT and the data privacy models employed in order to safeguard the data. We have also summarized some of the basic principles and practices that needs to be considered in order to secure an IoT network. Thank you.